Hello and welcome to today's Tech Talk on Hexaly on Nextmv, how to run, test, and manage models with DecisionOps. My name is Haley and I'm part of the Nextmv team. I'll be your MC for today. Today's presenters are Ryan O'Neill and Fred Gardi, CTO of Nextmv and CEO of Hexaly. Today's session is going to include a quick overview that will help orient everyone to Hexaly on Nextmv and some DecisionOps concepts, followed by a quick optimization speed run presented by Ryan, and then the bulk of our time will be spent with Q&A between Ryan and Fred. For that time at the end there, we encourage folks to use the Q&A feature at the bottom of your screen. You can also use the chat off to the side. Just keep an eye on that hosts and panelists versus everyone toggle to make sure your question or comment goes to the right audience. And with that, Fred and I are going to step back into the Zoom backstage while Ryan covers a few items to get us started, and then they'll tee up the Q&A. So Ryan, take it away.
Thank you, Haley, and thank you so much, Fred, for joining us today and everyone for tuning in to our little tech talk. So we're going to start today. We're talking about two technologies merged together. One is the Hexaly optimization solver, and the other is the Nextmv platform. And we're going to show how they work really well together to solve difficult problems. So if you're not familiar with it, I'll give a very brief intro to Hexaly without stealing Fred's thunder. Basically, it is a hybrid mathematical solver, and what that means is it combines different technologies to do optimization into a unified whole, and those sort of make each other powerful and more and reinforce each other. It was developed by Fred Gardi, who's joining us today, the CEO of Hexaly. It aims to provide an approachable, scalable method for solving optimization problems, and we can speak from experience that people are using it for things like vehicle routing, order picking, scheduling, and other problems like that. I also used it last year quite a bit for an Informs talk and found it was quite adept at solving some very difficult problems. And we'll get more into that, of course, in the Q&A. The other technology that we're combining this with is the Nextmv platform, and that's sort of illustrated here as this infrastructure platform that helps you cross the divide from model development to production. So Nextmv gives you everything that you need to do to move models from your local environment into a production hosted environment quickly, to work with your stakeholders, to run experiments and manage rollouts and changes to models over time, and to handle observability. So when we combine these two things together, we have essentially optimization combined with infrastructure, which just gives us the ability to deploy models to remote infrastructure very easily, to test those models and make sure that they perform well over time or as businesses change. And then we can do fancy things like ensemble runs where we auto-select best runs. We'll actually show that today. We can integrate with CI/CD, and we can communicate and manage our stakeholders better. All right, with all that out of the way, let's dive into a speed run where we'll actually show these things together. So the example that we're going to use today is actually right out of Hexaly's documentation. It's called the prize collecting vehicle routing problem. This is a very difficult problem. And basically the premise here is we've got a bunch of vehicles that start at some depot and end at a depot. We're planning in advance. So we're giving them their schedules and then they're going out into the world. And we're trying to maximize the prizes or tips or payoffs that these vehicles receive when they get to their stops. And we may not service every stop. And so the question is like, which one should we service? What vehicles do they go to? And what sequence should they be serviced in? And you can, of course, look at Hexaly's documentation if you want more information about this particular problem and the code that goes with it. To adapt this to Nextmv, what I have done is started with a Nextmv routing input. So you can see here, I've taken just one of ours and sort of adjusted the inputs a little bit. So what it has is a depot location. So this is where all the vehicles start and end. This might be where we keep our fleet. This might be our warehouse, that sort of thing. It has stops, which are essentially service requests with locations attached to them. This is, of course, essentially random data, but each stop has a quantity. So this might be resources used or time used. And then where it gets interesting here is I've added a tip field. And this tip is essentially a payoff for a driver visiting this stop. And I have a range here, which indicates that it is uncertain. So I don't know what it's going to be in advance. This is where it diverges a little bit from the Hexaly documentation. And so we don't know in advance what the tips or the payoffs are going to be, but we're trying to create these plans a priori. before the operational period. And then we have a set of vehicles, each of which has a capacity, and we may or may not use all of them. There's probably a fixed cost associated with each vehicle. So given that input, here is the actual Nextmv app, which we've put this Hexaly model into. And so the first thing that we do is we use the Nextmv Python library here to wire up the parameters in the input. So we take things like the random seed from the configuration. One thing that I'm doing that's slightly different here is I'm using a random number generator to generate those tips or payoffs in advance. And we're going to do what's called a scenario-based approach, where we generate a bunch of scenarios, and then we optimize each one of these using Hexaly, and then we choose the one that's going to be robust to all of the scenarios. So we're going to optimize a scenario, and then we're going to look at the expected payoff and choose based on that. And the combination of Hexaly and Nextmv makes it very easy to do that kind of approach. It's not the only kind of approach you can do here, but it is a nice and convenient one. And it's what we'll show today. We compute a distance matrix, we do some logging, and then we actually solve the model. This model class is where I've actually put the code from Hexaly's website. And so you can see there's just some pre-processing here. There's all the constraints for the model. And then finally, this is a very interesting part. We have 4 different objectives which we're trying to balance. So the first thing that I want to do is maximize the payoffs. So this is essentially selecting stops and the payoffs that go with them, the tips. I want to then minimize the vehicles that I'm using because there's a fixed cost associated with that. Then I'm trying to minimize the range in the payoffs for the different drivers. I want to sort of balance pay among the drivers such that there's not a huge discrepancy where like one driver gets $10 and another gets 1,000. And then finally, I want to minimize the total distance that the vehicles have to drive. And Hexaly makes it very easy to deal with all these different objectives that I have in my business. All right. Once I've got the actual model code written, this is what it looks like inside of a Nextmv app. And so you can see here, I've got my app container for the model, and it has sort of images and so on associated with it. I can run my app. I'll do that by just cloning an existing run. And you can see it has all these locations which display in the output. I can add a custom visual to this if I want. I'm just going to click run, and I can run it for a duration of 5 seconds. Once I do that, you can see that the run is queued. It will be picked up by the infrastructure, and it will be running. It is currently running. And I'll get an output in a few seconds. I'm just going to load one. You can see the queued one here. I'm going to load one that I've already run. And so you can see this is a run that already went through the system. And it has information like how long it ran for and what was the size of the output. It also has all of these statistics over here. And these are things that I put into my JSON blob for my output in using the Nextmv Python library. And these are essentially KPIs that I care about. So things like what's the total route distance, or in our case, I care about what is the expected range on tips for the drivers. I can also get the result, which has the actual routes, the sequences of stops that the vehicles go on, and things like the Hexaly logs. So you can see here it's balancing the different objectives. All right, so that's just an individual run. The question here is, how do I deal with this sort of balancing goal when I'm dealing with some different scenarios that I've generated? And one way that I can do that is I can run a scenario test. And so I can go here and I can go into experiments and I can click new scenario, and I can define it, and I can say what are the inputs. I can give it different configurations or instances that I want to run, and then I can tell it the number of repetitions and create a scenario test. In our case, what we're doing is we're generating scenarios using the random seed on the model, and then we're selecting from all the different scenarios based on the one that's sort of most robust in some measure. So I'll load a scenario test where I've already done that. So here what you can see is a completed scenario test, which has done all the runs for me already. Those are all down here, and I can go into each one individually, and then I can look at aggregate statistics on this table at the top. And so I'm going to pull up the result value. So this is the total tips to the top, and then I'm going to put the expected range of tips here. I can see that in a tabular view, or I could switch this over to scatter chart and look at something like this. And here what I see is I'm one point down here, which gives me a pretty high scenario value, i.e. total amount of tips, and a pretty good range, i.e. a low range. So it balances them well. And so operationally, this might be what I actually use. But then the question is, how do I automate this? And so in order to do that, I create what's called an ensemble definition. And so inside of the infrastructure, I can essentially do the same thing, but have the infrastructure manage it for me. And I sort of run it the same way as a scenario test. I give it the instances and configuration to run, and then I give it a rule for selecting the best plan. And so in this case, what I'm going to do is try to minimize that range. Now, an ensemble run looks just like any other run, and I'll load one that I've already done here. So you can see it's got the run details on the left, the statistics on the right. The big difference is what it has done actually is run it a bunch of different times and then used that rule to select the one that I want for me. Other than that, it looks exactly the same, but I'm using the infrastructure to generate all of these scenarios and do the model selection at the end, or the output selection at the end. All right, that was a very, very, very fast overview, but I think it sets us up well for the next section of our talk, which is Q&A. All right, excellent. All right, so Fred, I just heard a very, very quick and high-level overview of Hexaly combined with Nextmv, just to get us warmed up. Could you, in your own words, give us sort of a brief orientation about how Hexaly got started, how people are using it, what was your approach to building it, what are the best use cases for it, and that sort of thing?
Yes, sure. Thank you. Thank you. Sorry, my voice is not that today, but would be okay.
It's good when you're around.
Yeah, so we started as a heuristic solver. Some of you knows us as a local solver. Started some time ago, 2007. I built the first prototype. The very first idea was to have a solver integrating local search techniques. They are very powerful for practical optimization if you want to get speed, scalability, so high quality solution very quickly. These techniques are good. A lot of practitioners implement them. By hand is very tedious. So the first idea was to have a solver, a kind of solver like Cplex, but based on these techniques. So we started as an internal product. We used it on our own service projects. It was good results. We save a lot of development times, and so we started to talk about that outside. And a few people wanted to test it, and the feedback was good feedback. And so we decided to commercialize it, to make it a long-term project and to invest in it. And very quickly, we wanted to move from this very niche solver to a global optimization solver, competing with Cplex. It was a top solver at that time. MILP solvers, mixed linear programming, especially, and so this is what we have today. I think it took 10 years to build, but we have something quite good now with this vision of an hybrid solver, a solver that hybridize different paradigms, different techniques. So first, the modeling. Modeling is a combination of different constructs coming from mixed integral linear programming, nonlinear programming, and constraint programming. And in the backend, the algorithms also are combined from different domains. And so in the end, we have a combination of exact and heuristic techniques. What makes a real difference still today are the heuristics techniques. And we have this speed, this scalability I mentioned. And so where it delivers really on the types of problems as you mentioned. So routing, vehicle routing, route optimization, the solver is really good on these problems. Scheduling, production scheduling, workforce scheduling, also packing, clustering, assignment, matching, location, network design problems. So mostly this space is supply chain and workforce optimization. We don't claim to be the very best on everything. Energy finance, we are working on it. The work is in progress,
Yeah.
but today where Hexaly makes a difference, it's really on supply chain and workforce management problems.
Yeah, I think one of the interesting things about that is the story that I usually hear is exact methods adding heuristics, and starting with declarative modeling, but then this sort of goes in the reverse, and that's sort of an interesting journey. I know you just released Hexaly version 13.5. It actually would have shown up on the website, but I clicked the little X that took the notification away. What stands out to you, or what are your favorite features about this release?
Yeah, so we focus primarily on the problems coming from our clients. We also take what we get from academics because it's free for academics, Hexaly. So we take models, and for at each new version, we want to have a version that solves the problem we didn't solve, but focusing on clients first. I didn't mention them, but so we have Amazon, FedEx, Procter and Gamble, Starbucks, Bosch, Sony, Airbus, and so they use it for the problems I just mentioned. So routing, scheduling, packing, etc. For this new version 13.5, we have focused particularly on price collecting, vehicle routing problems, or team orienting. So these problems where you collect rewards, so you show one of them. So on routing, price collecting, and dialer ride problems as well. Problems coming from mobility, not this last mile delivery, but more mobility, people transportation. We have improved a lot. And on scheduling, the big thing is on batch scheduling problems. We have made a really a dramatic improvements on batch scheduling problems that are really, really difficult, especially the ones coming from industry. Yeah, it's mainly the big improvement we have also on, I mentioned packing, clustering. We have improvements on these categories, but the work remains focused a lot on routing and scheduling, where is the big demand.
Yeah. Yeah, that's exciting. I mean, those on-demand last mile problems are super tough, and they've got really, really tight, deadlines on solutions. So that's cool to hear. Changing gears a little bit, let's talk about sort of optimization in general. How do you see the growth and adoption of optimization in business and industry, and how is that changing in the future, do you think?
Uh, I think since the very beginning, operation research, optimization, um, there is a slow growth. There is a growth. The growth is that there is not an explosion. Uh, so today, I'm not sure it has changed. I'm not sure it accelerated now. But this is really steady, and we see more and more companies coming to optimization. And so the very big ones, they already use it. They know. But we saw more and more mid-sized industrial company on one side. So all the companies, that use Excel for planning,
Right.
scheduling, or routing, this is everything is done on Excel. The planners use Excel files, and so now they want to have applications, web applications, and they want to have optimization, so automatic planning. So on the one hand, mid-sized industrial company, we also see that through the number of software companies, a lot of software companies, small ones, small and medium businesses, uh, that are in this space of supply chain workforce as well. A lot come to us to add to add optimization as a feature for the clients. And they want to do optimization. So you have developers, not data scientists, software developers in these small and medium businesses, software companies that want to do optimization. And this is also where I think the offer by Nextmv is really great, because we at Hexaly we want to offer the technology to solve. Now we know that, as you say, that there is a gap between prototyping, developing,
Yep.
having things running in production. we know that it's particularly hard in operation research. It's hard in software engineering. We know that it's about DevOps, etc. But in OR, it's really difficult. Building robust industrial grade optimization engine is really difficult, and it's where Nextmv provides something great. And I think the combo, uh, Hexaly inside Nextmv provide a lot of value to developers, and especially to these developers in small and medium business that want to add optimization to their solutions.
Yeah, I think that's the move from like really large scale organizations to mid size is something we're seeing too, and that's really insightful. Like historically the beginning, as you know, was all just like government and military with massive inputs and scale. Um, so as you talk to some of these users and practitioners, especially as it moves toward mid-sized businesses and technology companies, what sort of challenges and opportunities seem top of mind to them?
Uh, yeah, so mathematical optimization, um, if I call it mathematical optimization or operation research, it was the perception was to be very complicated. The perception by companies, by business leaders, by the people, even software developers, so that something complicated. Uh, and also, I think that the teaching is part of the problem. I don't know if this is a problem, but we have focused a lot, maybe too much on emphasizes just on the math,
Right.
the algorithms, not really on IT. I remember a time where when you learn OR, you were really focused on algorithms,
Yeah.
and even on the theory behind the algorithms. All the stuff around IT, software quality, software engineering, project management, best practices, all of that, we didn't talk. And it resulted in, according to me, in my opinion, it resulted in in a lot of failures, a lot of poor executed or projects. So you want to implement very complex things. You don't focus on the business needs. You don't focus on software quality, and in the end, you have a kind of prototype that don't deliver. Uh, and so again, here Nextmove is filling the gap, offering some tools so that software developers, data scientists can build really industrial grade applications, and so that business users have things that are really delivering results and value.
Yeah. Yeah. You're bringing me back to solving memories or maybe memories of solving simplex tableaus by hand. I assume that you had to do that
Exactly.
too with the Wayne and Winston
It's
book
what I
open.
mean. Exactly.
Yeah,
I
yeah,
did. I did too. Yeah, I did. I did.
yeah.
I did. I did.
And
And
computing
I
cutting
think that,
plans and stuff.
all the people that you have some people in business schools, people that become managers after, I think they have this vision of a discipline that is very confidential for very smart people, something niche. And I think we really need to work all together to make it really to democratize it
Yeah,
and in all sense. Of course, we will keep the best from the math, the algorithms. We have it, but we really need to democratize.
one of the things that it feels like was a big step toward that was the introduction of Python APIs and the standardization of
Yeah,
Python sort of as the lingua franca of optimization. And
yeah,
that didn't happen that long ago. So that's been a
yeah,
nice move in that
exactly.
direction.
10 years, 15 years ago.
Yeah,
Yeah, yeah, yeah,
yeah.
yeah, yeah.
So if I'm say like a business leader or a CIO or something like that who knows that I need this optimization thing in my organization, maybe I have a data science team, I've never used it before. What sort of things do I need to know? What do I keep in mind as I pull that into my organization and build it into a discipline?
If you have a data science team, in-house. Um, I think that I think what you need to check is that the data science team is really have this double face. You see, uh, being strong technically, because being technically strong is always good. I think in algorithms, the maths, knowing how to model the solvers, the best of software engineering practices, having the right tools. Nextmove, for example, you have the best toolkits, you have all the maths, etc. Technically, you're strong. It's very important. It remains very important, I think, to be strong, but very customer focused.
Yeah.
I think the community had this discussion about mathematical optimality, about optimality hundreds, thousands of times. I think we focus too much on mathematical optimality of what is optimality for a business, especially in business where things are changing every day. I think focusing on what people needs in operations, listening to the operational people, what they want, what they need, what are the KPIs they want to optimize, in which order, etc. It's really the big part of the job, and I think you need to check that before starting for a project, that the team is well fit well this view, this vision.
One question that we had in the chat was about participation in the Hans Middleman benchmarks. I know those have been a little bit those have an interesting history over the last several years. I'll let you
Yeah.
respond to that as you see fit, but I'm curious, how do you think about testing and experimenting on Hexaly, sort of as you release it and the models that you build with it? I know you have this very tight integration with your users and the problems that they're solving.
So I think, yeah, so I think there are two things. The benchmarks, a pure benchmark, academic benchmark, or really pure performance benchmarks. It's something. Since Hexaly is not exactly a MILP solver, we have a higher level modeling interface. We don't want, and we can't compete, and we don't want to compete, because if you use Hexaly just like a MILP solver, it doesn't work. So
Right.
you have to remodel your problem, and so it's part of the game, and it's not so simple. In the end, it's even simpler because we have these higher modeling constructs. But for example, you see, I think these benchmarks for solvers are really interesting. Okay, you want to have optimality in 1 hour, uh, but for example, at Hexaly, this is not our focus.
Right.
The Mittelman benchmarks, it was really, you want to judge the solver, or are you able to get the optimal solution, the very optimal, the mathematical optimal solution, proven in 1 hour? Is it what the business need?
Right.
Naturally. So at Hexaly, we have our benchmarks. People can appreciate. We let them check. We mainly have 1 minute as running time, because the feedback from the users, the feedback from the business users, even not the software developers, but even the business users, this is what they want. They want to have solution very quickly, because they navigate different scenarios. This is what you show. With Nextmv, you can test different scenarios very quickly, even stochastic optimization. You want to add some stochasticity, very practical with Nextmv. And so to do that, you need to go quick. You cannot solve 1 hour and then change your data, resolve. So 1 minute is really the running time we have for our benchmark.
Yeah, that makes sense. Yeah. And certainly that's something that, frequently I've seen it especially when people are doing something like routing problems or something, and they need to move them into a production environment, like heuristics And these sorts of technologies seem to be like a place that they turn to very frequently, and they stop doing things like measuring optimality gaps so much, and they just say like, well, how good is it doing, and what is the sort of time limit and the urgency of the solutions?
Yeah, so your question is about the optimality gap?
More about just how do you how do you evaluate new versions of solver and models using on the models that you're testing on?
So the improvements.
Okay.
Yeah, so this is so it's about testing again and having the right tool to test efficiently, to run many scenarios, and to be sure that yeah you have no regression. This is a big thing, and this is again where I think that the tool you provide is great, because we saw it. We provide performance to developers. So when you deliver something where people they test and they see, oh, it seems to be not so good. The new version is not so good compared
Right.
to the previous one. It's really a no-go, a big no-go. Very, very bad thing. So for us, it's very important to have the right tool to make this testing very clear. But also in industry, this is the same
Mm.
with business users. You come with your new version, you're very happy, you have worked a lot, you deliver, they test, and they say, sorry, but it's not so good. And this instance seems to be worse than before. I don't understand, etc. And yeah, this is where Nextmove is great with the ensemble, with everything. You show you can make this test uh, with a very scientific, a very rational
Right.
approach, and having numbers and checking the numbers. And this is really what is great to me.
All right. Well, I think we are at time.
We are, and I've reemerged from the backstage to say so. So I appreciate the conversation, Ryan and Fred. I know that there's a couple of questions that are still floating around in the background, and we'll make sure to address those over email after today's session. With that, we're actually going to wrap for today's time. We really appreciate everyone joining today. The session is recorded, and we'll share it out over email with everyone. If there are follow-on questions for Ryan or Fred, don't hesitate to be in touch. Again, we'll give folks a way to reach out and connect. Ryan, Fred, thank you so very much for today's session. Really appreciated it, and we'll see everyone next time.
Thank you, Fred. This was great.
Thank you. Thank you. Bye.